Okay, today we're going to look at writing the equation of a piecewise function. And as we do this, you'll have to understand that you don't really have a set number to start on. You don't have a set number of equations to make. It's based on the graph. So if your graph has two pieces, you need two equations. If you have open and closed circles, that does give you some information about your domain. So a piecewise function is made up of an expression, which represents linear, quadratic, exponential, whatever kind of graph you have, and a domain. We're going to start with domain because I think that will be easier to understand. So when I look at this graph has an open and closed circle, or any circles at all, on -1. The first piece is to the left of -1. So that means that all of it would come from looking at -2 or -3. The other piece comes from numbers that are bigger than -1 to go to the right. Now, one of those circles is colored in, and that circle is the one who gets the equal to mark in the domain. So the one on the right has the colored in circle, so the second domain gets your equal to mark. And it's just that simple. You just look for those circles, and you say less than for the left side and greater than for the right side of that piece of the graph. So now let's look at what kind of graph we have. Now this first piece to the left, the ones that are below -1, is called a constant function. And a constant function basically is a horizontal line equation. So a constant function stays the same all the time, so there can't be any math being shown. So that constant function is -5 because it stays -5 the whole time. It doesn't change, and therefore it makes your function not have any adding, subtracting, multiplying, or dividing. Now on the other side, you have linear. And this linear, when you look at it, you need a y equals mx plus b equation. Well, the y-intercept is actually showing on this graph. And I could count up 1, 2, 3, 4, 5, and over 1, and find out that the slope is 1 to the left, meaning -1, and my rise over run would be 5 over -1 or -5. So our equation here would be -5x plus 1, because this is your y-intercept and b is equal to 1, and we're making an mx plus b equation like you did back in 8th grade. So that's a piecewise function. Now, as we look at each of these, we're going to look at different kinds of pieces, so not everything's going to be straight. But in our next one, we have 3 pieces. The first circles that state your domain are right here on -2. So there's going to be a piece that is less than -2, and we'll talk about equal to and coloring it in and all after we get them written. Then our second piece starts on -2 and goes to +2. So that's a between. And when you have 3 pieces, you're going to have a between the greater than and the less than part. And then your last one is going to be x is greater than 2 because it's to the right of the last vertical line. So you broke it into 3 pieces. The first one started before -2. The second one's between -2 and 2, and then the last one's after -2. Now, your colored in circles are on the solid line from -2 to +2, so your middle one gets the equal to mark. So you have to look for where those colored in circles are to know which one of your domains gets it. Now I want to talk about that particular equation because that's the easy equation to talk about in this particular one because it's constant. It's on -1. It stays on -1 the whole time, so the middle equation is -1. Now, to get these other two straight line equations, we're going to have to first find the slope, because these are both linear. So I'm going to count up 1, 2 over 1 to the left. So my rise over run on this side is negative 2 over, well, it's really negative 2 over negative 1, which is negative 2. Now, I don't have a y-intercept because it's not crossing the y-axis on that line, but I can go down 2 and over 1 and down 2 and over 1 and find out that it's at negative 2. So this one's negative 2x minus 2. And don't always think that that's going to be the same every time, because it's not. Those two numbers just happen to come out the same. I can do the same thing with the linear on this side. I can count up 1, 2, 3 over 1. And that makes my rise over run 3 over 1 or 3 for the slope. Then if I count down 1, 2, 3 over 1, 1, 2, 3 over 1, my b is going to be 1. So I can write my y equals mx plus b equation 3x plus 1. So you've got to be able to count rise over run. You've got to be able to find a y-intercept. Now, the only other way you could find those two linear equations is to pick off 2 points on the line and stat calc. That's another way that you can get those equations. But you have to make sure you're using whole number of points, because it doesn't work very well if you're not using a whole number of points. It's almost impossible to estimate. So now let's look at some that maybe aren't straight. So in this problem, we have 3 pieces. And how I know there are 3 pieces is because the colored in circles tell me one stops and the next one begins. And this one happens to be all connected together, so that's also another thing that we need to look at. Some piecewise functions are in pieces that are broken, and some pieces are together, like this one. So here's where negative 1 starts. So x is less than negative 1. And here is where the next part stops on positive 2. So that'll be our between from negative 1 to positive 2. And then the last one will be greater than 2. Because when you do these piecewise functions, the first one's always less than, the last one's always greater than. And if you have 3 parts, there's a between in the middle. Now, I can't tell which one had the open circles and which one had the closed circles on this graph, because the open circle is covering up the closed circle, or vice versa. So it doesn't really matter which one you put the equal to marks on, as long as you just put it on one of the negative ones and one of the 2's. So the easiest thing to do would be put it on the between. Now let's start off with this linear equation and see what it comes out to be. So if I count down 1, 2 over 1, that would be negative, and left is negative. So that's going to be positive 2. And if I count up 1, 2 over 1, that tells me my slope is 5. So my first equation is going to be 2x plus 5. Now when you write a quadratic, we're going to do it in vertex form. This quadratic only went up 4 from the origin. And so that's going to be x minus 0 plus 4, because it didn't move left or right, but it did go up 4. Now, I don't know what the number in front of my parentheses is, so what you'll need to do is you'll need to take the 3 points off this graph, and I'm going to erase some of this so we can focus on the 3 points we need to. You'll take this point, negative 1, 3, and you'll take this point 0, 4, and you'll take this point 2, 0, and you'll stat calc this part of your problem. So we're going to come back and do that in a minute, because my calculator's not up yet. But in this problem, we're looking at the last piece of our graph is the absolute value, v. So I have to know how to do that by hand. I can't get that off the calculator. So when we get done doing the stat calc, we're going to come back and talk about up, down, left, right with that one and show how to come up with that equation. All right, so here we're going to go to stat edit. And I don't know how many points are in here, so I'm just going to go ahead and delete what I've got. So it was negative 1, 0, and 2 were my x's. Now I got to go back and see what I had. -1, 0, and 2. 3, 4, 0. 3, 4, 0. So then we're going to stack count quadratic because we want the quadratic equation. And here's our quadratic. Now this right here, 2.6 e to the negative 13, means that's a round off error. That round off error rounds to 0 because if you moved the decimal 13 places to the left and added zeros to the front for scientific notation, that'd be a lot of zeros and that'd round to 0. But what you want off of this stat calc is this number right here, because that's the number that shows whether it's stretched or compressed or whether it reflected. And that's what we need to put in front of our equation. We're not writing ax squared plus bx plus c format today. We're writing vertex format. And so if I write that -1 out here, then it looks like the format of up, down, left, right, did it reflect. Now our last piece over here is this absolute value v. And this part right here just went 3 to the right and 2 down. So when we put that into our absolute value problem, 3 to the right will look like -3 and 2 down will be -2. Then we can count rise over run between any two good whole numbers and see what the rise over run is. So up 2 over 1 is going to be 2. And that's our number that goes out in front. I don't stat count to get that number because it's straight. You can actually count it. But for the quadratic, I had to stat count because it's on a curve. And be very careful, because what a lot of students think is you can count down and over to this point and get that slope, but that doesn't work every time because sometimes it might need points in between there to be the right slope. And so you need to make sure that you realize curves don't count slope like we do with straight lines. All right, we're going to do one more. This one has a quadratic for the first piece, a linear for the second piece, and an absolute value for the third. So first, we see that it's broke at -4, so x is less than -4, and it's colored in on that. On the next part, we have a linear part between -4 and +2. So -4 is less than x is less than 2, and the 2 is colored in on that one. And then the last one's going to be 2 and up. And it's not going to be equal to 2. It's just going to be up from 2 with an open circle. All right, so next we're going to do our quadratic. So with a quadratic, you make a parentheses squared. This graph just went 4 left and 3 up. So if I fill that part in to get to this vertex right here, I went 4 to the left and 3 up. So that'll be +4 +3, because you always make the left-right number the opposite. Then I can take that point, this point, and looks like maybe that point. Oh no, that one. There's 3 or 4 points there you could take and stat calc to find out what your number in front is. And we're going to come back and do that in a minute after we finish making all the equations. So on the next one, I see it crosses the y-axis at -3, so b is equal to -3. If you start on the bottom end, you'll realize you're between two lines, and that would not be a good place to count slope from. So start up here and go down 1, 2, 3, over 1, 2, 3, 4. So down 3 over 4. It was down 3, so that's negative. Right 4, which is positive. So that's going to be -3/4 x minus 3, because you put your slope, rise over run, and your b goes on the end. For the next one, we have absolute value, so we got to see where did it move. It moved 5 to the right and 5 up to get to this vertex. So that means that I'm going to have x minus 5 and plus 5 on the outside. Then I got to count rise over run, down 1 over 1, 2, 3. So that's going to be -1/3 because it's opening down. That means it reflected. And I know that this quadratic is also opening down, so maybe when we make our points, -4, +3, -5, +2, and -6, -1. I don't know if I need this one way down here. We're going to leave that one out. Okay, so we're going to go back to stat edit. -3, -4, -5. Well, I did something wrong. Let me quit and go back to stat edit. -4, -5, -6. -4, -5, -6. Alright, now I got to go back and find the 3 points for the second column. That would be 3, 2, and -1. 3, 2, -1. Stat calculate, number 5, quadratic. It also come out -1 for A. Now remember, we're not using these other numbers. We're only using the A number off our calculator because these other numbers are a different format. Now, not every one of them is -1, so don't get used to that because you may get some that are not -1. So that's how you do the lesson in 3.3 for writing the piecewise functions from a graph. So now you should be able to pull up the worksheet and see if you can work out the questions on there for your homework.